Hi everyone, let's present our paper, PrimHOI, a framework for generating complex human-object interactions by composing reusable interaction primitives. Synthesizing human-object interaction has great value in animation automation and embodied robotics. Most current methods focus on simple interaction with single object and short horizon. However, in our daily life, our interaction activities include long horizon motion with temporal composition and spatial composition. Given a textual task and a 3D scene, we aim to output a detailed interaction motion. It can have diverse plans. For PrimHOI interaction synthesis, precise geometry between humans and objects is hard to learn from limited data. It usually requires a large dataset to achieve better quality. However, for compositional PrimHOI motion dataset, it requires enormous efforts for data collection and manual refinement. Existing compositional generation methods use either high-level planning or contact planning to achieve temporal compositional PrimHOI motion generation. PrimHOI motion generation with both spatial composition and temporal composition is underexplored. We aim to achieve zero-shot transfer from existing motion generation modules. To achieve zero-shot generalization, we need to rely on generalizable representation. The current whole-body interaction representation lacks generalization capability. One key observation of our method is the interaction patterns repeat among different local interaction regions. We call these patterns as local contact primitives. The observation motivates us to build our method. PrimHOI integrates a high-level symbolic planner that sequences primitives with a low-level generator that realizes each motion physically. Instead of all relying on large language model for high-level planning, we build the planning by more accurate descriptions in PDDL. The high-level planning steps including ELM problem translation and PDDL symbolic planning. The final planning results are state predicates that describe subgoals. Given symbolic subgoals, we predict contact points and object placements, then optimize the body pose to satisfy these constraints realistically. We first generate the contacts on the objects. Then we place the objects based on prior or relative relationships with placed objects or body parts. Finally, the human body is optimized to achieve the body contacts. After the key pose generation, we generate the intermediate motion. We first plan the object trajectory with SDF collision avoidance. The human body contact points are inferred then by attaching contacts to the object's trajectory. Using the inferred contact point trajectory, we use a body control model called local control to generate the skeleton-based human motion. By enforcing the following optimization terms, we optimize the skeleton motion into a smooth and collision-free human object motion. Here are 3 distinct motion solutions generated by PrimHOI, each following a different interaction strategy yet completing the same task successfully. These are the key poses of Plan 1. Let's check the video result of Plan 1. These are the key poses of Plan 2. Let's check the video result of Plan 2. These are the key poses of Plan 3. Let's check the video result of Plan 3. There are more results. PrimHOI can handle various objects and contact patterns. Here are the comparison results of different high-level planning methods. You can see that the PDDL PrimHOI does improve the accuracy and diversity of the planning quality. These are the comparison results of different low-level generation methods. As shown, local control fine-tuned from OmniControl does keep the naturalness and smoothness of the human motion with contact guidance. Thank you for watching. Welcome to check paper and code in our website.